Magandang araw po sa ating lahat. Right now, magsosolve tayo ng mga random problems about generator efficiency. Let's go to our first problem. The full load losses of a 20 kilowatt 230 volts generator are as follows. The field loss is 180 watts, armature loss 1,200 watts, windage and friction losses 550 watts, iron loss, eddy current na ito at saka hysteresis loss 500 watts. Determine the efficiency at full load. For this problem, gamitin natin yung formula percentage efficiency equals the power output over the power input times 100%. Ngunit ang power input can be expressed as power output plus the total power losses. Kaya dito, magkakaroon tayo ng power output, divide this by power output plus power losses times 100%. Yung 20 kilowatt or 20,000 watts, ito na po yung kanyang power output. Kukunin na lang po natin yung total power losses. So for the power losses, nandyan na po yung 180 watts plus 1,200 watts plus 550 watts plus 500 watts. Ang total power loss ay 2,430 watts. Substitute natin yung mga value dito. We have the percentage efficiency equals, the power output is 20,000. Divide this by power output plus power losses, 20,000 watts plus 2,430 watts times 100%. So the percentage efficiency equals 89.17%. Here we have another problem. A shunt generator supplies a load with 106 amperes at 125 volts. The shunt field resistance is 31.2 ohms and the armature resistance is 0.11 ohm. Determine the shunt field copper loss and the armature copper loss. Ang terminal voltage niya ay 125 volts. Ang line current, that is 106 amperes. Ang hinahanap natin dito ay PSH and the armature copper loss. Ang formula nito ay ISH squared times RSH. Dito naman, we have the IA squared times the armature resistance. So given na yung shunt field resistance and armature resistance, ang kukunin na lang po natin ay mga shunt field current and armature current. Una natin pwedeng kunin yung shunt field current. ISH equals VSH over RSH. Dito, 31.2 ohms at dito naman ay 0.11 ohm. Ang VSH, since shunt generator ito, is equal to the terminal voltage. Therefore, we have 125 volts. Divide that by 31.2 ohms. 125 divide this by 31.2 ohms is 4.006 amperes. Substitute natin ito dito. We have PSH equals 4.006 amperes squared. Multiply natin ito ng 31.2 ohms. And this is 500.8 watts. Another formula na pwede natin gamitin para dito, PSH equals the voltage squared divided this by the resistance. We have 125 volts squared divide this by 31.2 ohms will give us the same 500.8 watts. Now let's go to armature copper loss. Kunin muna natin yung armature current. So nandito yung armature current and nandito naman yung shunt field current. Maglagay muna tayo dito ng node. Let's say that is node A, KCL. At node A, we have their summation of current in equals summation of current out. Ang pumapasok lang na kuryente dito sa node na ito ay IA at ang lumalabas sa kanya ay IL plus ISH. IL is 106 amperes plus ISH is 4.006 amperes. Ito, magbibigay sa atin ng 110.006 amperes. Substitute natin ito dito sa formula natin. We have PA equals 110.006 amperes. Square that, multiply this by 0.11 ohms. At magbibigay sa atin ito ng 1,331.145 watts. So, ito po yung ating mga sagot dyan. So, this is another problem. From the following data concerning a shunt generator, calculate the efficiency at full load. Rated kilowatt output, that is 10 kilowatts. Ang power output nito is 10 kilowatts. Yung rated voltage, so dito meron tayong positive, negative. The terminal voltage is 230 volts. Armature circuit resistance is 0.4 ohm. Field circuit resistance is 192 ohms. Yung rotational losses or stray losses is 750 watts. Again, the percentage efficiency equals the power output divide this by the power output plus the power losses times 100%. Sa power losses, we have the copper losses plus yung stray losses or the rotational losses. Ngayon dito sa copper losses, meron tayong dalawa. The armature copper loss and the shunt field copper loss. Kunin natin yung mga copper losses. PSH. Again, yung formula nito. And armature copper loss, I squared times RA. Unahin natin yung shunt field copper loss. Kunin muna natin yung shunt field current. ISH equals VSH, which is equivalent to the terminal voltage, divided by RSH. We have 230 volts divided by 192 ohms. This is 1.198 amperes. Substitute natin dito. We have PSH equals 1.198 amperes squared multiply that by 192 ohms, equals 275.521 watts. Let's go to the armature copper loss. Kunin muna natin yung armature current. Again, node tayo dito. KCL at node A. Summation of current in equals summation of current out. That is IA equals IL plus ISH. Okay lang po kung memorize nyo na po itong formula for shunt generators. Pinapakita lang po natin kung saan sila nanggaling. Kunin muna natin yung IL. For that, we have IL is equal to the power output divided by the terminal voltage. This is just from the power formula, which is P is equal to the current times the voltage. Nag-cross multiply lang po tayo para makuha natin yung line current. So power output is 10,000 watts. Divide that by 230 volts. This is 43.478 amperes. Yan, substitute natin yung IL dito. 43.478 amperes plus yung value ng ISH, 1.198 amperes. This is 44.676 amperes. Na pwede na nating isubstitute dito. PA is equal to 44.676 amperes squared. Multiply that by, ang value ng armature resistance is 0.4. And this is 798.378 watts. Solving for the total power losses, dahil ito, meron tayong PSH and also the armature copper loss. Power losses equals PSH is 275.521 watts plus 798.378 watts plus stray or rotational losses is given as 750 watts. And this is equal to 1,823.899 watts. Substitute na natin ito dito sa formula natin. Percentage efficiency equals 10,000 watts. Divide this by 10,000 watts plus 1,823.899 times 100%. Therefore, its efficiency equals 84.574%. Another problem we have here, a 220 volt shunt generator has an armature circuit resistance of 0.02 ohm and a shunt field resistance of 88 ohms. At rated load, it delivers 190 amperes and has iron and friction losses of 1,500 watts. Determine the efficiency. The terminal voltage is 220 volts. Armature circuit resistance 0.02 ohm and shunt field resistance is 88 ohms. It delivers 190 amperes. Therefore, we have the line current that is 190 90 amperes. And yung rotational or stray losses is 1,500 watts. Again, yung formula, percentage efficiency is equal to power output divided by the power output plus power losses times 100%. For the power output, that is simply terminal voltage, multiply that by the line current. We have here 220 volts, multiply that by 190 amperes. Meron tayong 41,800 watts. Now for the power loss, again we have the copper losses plus yung stray losses. Although for copper losses, meron tayo yung shunt field copper loss and yung armature copper loss. Unahin natin kunin yung shunt field copper loss. Formula, ISH squared times RSH. Kunin muna natin yung shunt field current. ISH equals VSH over RSH, and this is equivalent to the terminal voltage. Substituting the values, 220 volts divided by 88 ohms. This is 2.5 amperes. Na pwede na nating i-substitute dito. We have 2.5 amperes squared times 88 ohms. This is 550 watts. For the armature copper loss, PA is equal to IA squared times RA. Again, kunin muna natin yung armature current. For that, we have here Kirchhoff's current law. Nandito yung armature current. KCL at node A. Summation of current in equals summation of current out. IA equals IL plus ISH. Line current is 190 amperes. Plus, shunt field current is 2.5 amperes. This is 192.5 amperes. Substitute natin ito dito sa ating formula. We have here 192.5 amperes squared that. 192.5 amperes squared times 0.02 ohm is 741.125 watts. Yan, kompleto na yung given natin. Substitute na natin dito sa formula na to. We have power losses equals PSH is 550 watts plus armature copper loss 741.125 watts plus stray power loss we have there 1,500. 2,791.125 watts. Ngayon, kompleto na yung given natin. We can therefore determine what is the percentage efficiency of the machine. Percentage efficiency equals the power output is 41,800 watts. Divide this by 41,800 watts plus the total power loss, which is 2,791.125 watts times 100%. This is 93.74%. Last problem, a compound generator has a terminal voltage of 230 volts when the line current is 50 amperes. The series field resistance is 0.02 ohm and the shunt field current is 2 amperes. If the total losses of this load are 1,900 watts, what is the efficiency of the generator? Kung titignan natin, parang medyo complicated yung problem natin. Pero kung tutuusin, simple lang po yung problem na ito. Wala siyang binanggit kung ito ay short shunt or long shunt. Ngunit kung i-analyze natin maigi yung problem na ito, this is very easy. Dahil yung tinuko niyang 1,900 watts dito, that is already the total losses. Ibig sabihin, included na dito yung copper losses and rotational losses na pwede na natin kaagad-agad na gamitin sa formula natin. Again, the formula percentage efficiency equals the power output, divide this by the power output plus the power losses times 100%. For the power output, that is simply the terminal voltage, multiply that by the line current. So the terminal voltage times the line current, that is 230 volts times 50 amperes. This is 11,500 watts. Na pwede na nating i-substitute dito. And yung 1,900 watts, ito na yung power losses. Percentage efficiency equals 11,500 watts. Divide this by 11,500 watts plus 1,900 watts times 100%. So the percentage efficiency is equal to 85.82%. We will be having more problems dun sa mga next na videos natin. Hopefully, meron tayong natutunan ngayon. Maraming salamat po.